All right, welcome to The Explainer. Today, we're going to tackle a question that is, it's one of the first big questions we ever ask, right? You probably wondered about it as a kid, just looking up. It seems so simple, but the answer? Well, the answer is this incredible story about light, physics, and a little bit of atmospheric magic.
Yeah, so why is the sky blue? What is actually happening up there to make it that color? I'm willing to bet the answer isn't what you think.
So get this, the whole answer can actually be boiled down to this one idea. A secret rainbow? Our atmosphere? Playing favorites? What does that even mean? Okay, let's unpack that, and we have to start with the source of it all, the sunlight itself.
Right. So to get why the sky is blue, you first have to understand the light that's making this epic 93 million mile journey just to get to us. You look up, you see that bright white sunlight, right? Well, that's not exactly true. Our eyes are playing a pretty amazing trick on us. It's basically a beautiful illusion. So here's the deal. Sunlight isn't actually one color. It's a whole team of colors. You know, all the colors of the rainbow, red, orange, yellow, and so on, all traveling together in a single beam. When that whole bundle of colors hits our eyes at the exact same time, our brain just kind of mushes them all together and says, yep, that's white. But remembering that hidden rainbow, that is the key to everything.
Okay, so picture one of those rays of sunlight, that secret rainbow finally finishing its long trip from the sun. What happens in that split second it smashes into Earth's atmosphere? It all starts with a big collision. First, the sunlight hits our atmosphere. Then, bam! It crashes into all these tiny, invisible molecules of air. That crash sends the light scattering in every direction. But, and this is the most important part, not all the colors scatter the same way. Not even close. And this, right here, is where our atmosphere starts to, play favorites, just like in that quote from the beginning. It doesn't treat all the colors in that rainbow of sunlight equally. Some colors get special treatment, and others, well, they just get to pass right on through. So why does this happen? It all comes down to the shape of the light waves. Blue light travels in these really short, choppy, wavy little bursts. Because it's so jittery, it's way more likely to bump into an air molecule and get knocked off course. But then you have other colors, like red. Red light travels in these long, lazy, stretched out waves. It just kind of cruises right past most of those same molecules without getting bothered at all. So because blue light is just so much better at scattering, it ends up totally taking over the show. Let's look at how that actually creates the blue sky we see. Think about it like a giant game of cosmic pinball. While the red and yellow light might just shoot straight through, that blue light gets bounced around like crazy. It gets pinged from one molecule to the next, then to another and another. It's just getting sprayed and ricocheted all over the place, filling up the entire sky above us. And what that means is, no matter where you look up, there's some of that scattered blue light heading right for your eyeballs. And that is the big reveal. When you look up at the blue sky, you're not actually looking at something that is painted blue. What you're really seeing is an atmosphere that is just completely full of scattered blue sunlight, bouncing all around you and coming at you from every single direction at once. Okay, so let's tie this all together with one final idea, a little fun twist that really helps this whole thing click. I just love this way of putting it. It's perfect, right? The sky isn't some static blue thing. It's a live light show happening constantly. Our atmosphere is like the ultimate filter, taking in that full rainbow of sunlight and deciding, you know what? Today, blue gets the solo. And that just leaves us with a really cool question to chew on, doesn't it? If the color of our sky is all about what our atmosphere is made of and which color it favors, what about other planets? What color might their skies be? What does the sunset on Mars actually look like, where the atmosphere is totally different? It all just depends on which color wins the spotlight there. Thanks for watching.